Hi guys, so today we'll be solving this problem called find eventual safe states. Let's read it. There is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a zero index to the integer array graph, where graph of I is an integer array of nodes adjacent to node I, meaning there is an edge from node I to each node in graph I. A node is a terminal node if there is no outgoing edge. A node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. Return an array containing all the safe nodes of the graph. The answer should be sorted in ascending order, right? So we've been given this entire graph and we need to return an array containing the safe node. What is a safe node? A safe node is basically um, a, a node if every possible path starting from that node leads to a terminal node, right? So a safe node can be like 4, right? 4 is actually like, let's consider a safe node as 2. So from 2, you're actually going to 5, right? And 5 is a terminal node because 5 does not have any path or edge to any other node, right? 4 is a terminal node as well because it's directing to 5, where 5 is having no edge to any other node. 5 itself is a safe node because it is not having any path to a terminal node, which is basically, having any path to any other node, right? And similarly, 6 is also a terminal node and also a safe node because there is no outgoing edges, right? So we need to return the number of, or like the array containing all the safe nodes from the graph, right? So for the first one, the answer is 2, 4, and then 5 and 6, right? So we need to return that. So this is basically a diagram representation of this entire first example, right? Right. So how we can solve this? The approach for this would be, so if you see, we tried to get the nodes which are directed towards a node which does not have any other, you know, um, like path to other nodes, right? It's the terminal node, which means that there is no other path to any other node. It's just singular in itself, right? For example, 1 is directing to 2 and 3, and 2 is directing to 5, and 3 is directing to 0. So it's not actually a terminal node. It is directing to or leading to more nodes, right? So in this case, 1, 2, and 3, right? And 0. All of these are actually forming a cycle, if you see, right? They're forming a cycle. And these ones are exteriors and they are actually not forming a cycle. And if you start from any of these nodes, you can always lead to these four answers because, yeah, they are not forming a cycle and also they are exterior. And from the terminal node, if you iterate, you'll eventually get to these four. And yeah, that would be your answer basically. So, which means that we are kind of doing, like, what we are doing is we are saying that if any of the nodes do not have any in degrees, right? So degrees, right? So degrees are like basically, yeah, the directed graph that we have. So in degrees, if does not have any in degrees, then it's a terminal node, right? So 6 does not have any in degrees, right? Does not have any in degrees, so it's a terminal node. So the element or the nodes which do not have any in degrees, for example 4 does not have any in degrees, right? So 4 is also like having in degrees as 0. So all the nodes which do not have in degrees, we start the traversal from there, and we eventually go to nodes which have an in degree, but only from there is no other in degree to other nodes, right? So for 4, mm, yeah, it does not have any in degree. 5 does have an in degree, but it does not have any like it's not, first of all, directing to other places, and second, it's not like the in degrees are also like two of them, right? So 4 is from 4 is which is already a terminal node, which is already like a node which has no in degrees, right? So from 4 we reach 5, right? And we basically cancel this, right? If you see, so for 5, then 5 is does not have any degrees outside or in degrees, right? So 5 is considered. From 2 we go to 5, and similarly 5 does not have any in degree or out degrees attached to it. So 5 is considered in the safe node, right? From 5 you can actually reach, so the idea is that if any of the nodes have it in degrees equal to 0, we consider them first. And from there, whatever is led, like if we are led to other values, right, we go to them. We go to like the nodes which have other values attached to it. And that is kind of following the topological sorting, right? Where in topological sorting, we have, if U is directing to V, so U will come first and then V will come. So we'll visit U first and then we will visit V. So here 6 is visited, 4 is visited, 2 is visited, and then 5 is visited. So which means that we only visit the ones which have in degrees of 0. So when 4 is visited, the in degrees is cancelled. 2 is visited, in degrees are cancelled, and 5 becomes the in degree as 0, right? So that is the idea. And we can do topological sorting by applying the Kahn's algorithm, right? So that is the idea. Let's get to the coding part. Kahn's algorithm is pretty much a template, and in this one, we'll be using that template to solve it. Right. Let's get to the coding part. So first of all, I'll maintain the graph size, right? And I'll maintain an in degree array of size n, and I'll also create a adjacency graph of size n, right? And I'll just iterate through the graph. The graph array has been given in the format of um, the node, and it's basically the degree, the path which is forwarding from that node. So we go through that graph and we go through each node of that graph, which is creating a path from that node basically. And I'll put it in the adjacency list. So adjacency of node dot push back the I in it, and also in degree of node plus plus, right? Okay. Once that's done, I have the next step, which is I'll also maintain the queue, and I'll basically push all the values which are having in degree as 0. Then I'll push it in the queue, right? Right. Uh, Eventually, what I'll do is I'll maintain a, uh, first of all, like I'll do the Kahn's algorithm. So in Kahn's algorithm, we'll just use the simple BFS template. So queue size is not equal to 0. And from there, we have first is uh, we have value equal to q dot front, and then I q dot pop. I pop that value, and I'll also maintain a safe, safe states boolean array, which will basically populate the safe states which are basically visited. So safe state is value equal to true, right? And I will go through each of the uh, you know nodes which it's like that particular node is directing to the other node, where there is a like a connection between them. I'll go through each of them, which is the neighbors basically. So adjacency list of, you know, val, so whatever is there. First of all, I'll do the in degree of node minus minus, which is basically that I've visited that particular node. And if one of these in degrees become equal to 0, then I can just push the node in it, right? And yeah, that will be the idea. And eventually I have few things. So once that's done, I'll just iterate through the safe, right? So if safe states of I equal to true, then I can create a final answer where I'll push that, okay, that these values are, you know, safe states. And I return the answer in the end, right? So that is the idea where we are, first of all, what we are doing is creating an in degrees array, right? And from there, we have a adjacency list, which is pushing all the values of that neighbors, like which we are going to from that particular node, right? And then I'm doing in degrees, actually it would be I, in degrees of I plus plus, right? Like for that, you know, from 0 we are going to 1 and 2, right? So in degrees of 0 will be plus plus, and then q, and then I just check like whatever the in degrees of I equal to 0, I'll use that and perform a BFS here where I'm just checking if q is empty, sorry, in degrees of node is equal to 0, then I'll use that and push it in the queue again, right? And yeah, safe value is equal to true. So the ones which are we are able to traverse or which are not in cycle, we are able to put it as true, and then I just pick them up and put it in the final answer. Let's run the code to see if everything is working fine. Um, yeah, size. Cool. I hope you guys understood the problem. Thank you so much.